We continue Unit 6, Solving Systems of Equations, with elimination. Use elimination to solve the following systems. Notice we have three variables, x, y, and z, just like we did for substitution. To begin, let's see if we can find something that we can eliminate. Let's look at the two equations that only have two variables. Notice that the second and third equation, we can eliminate y if we combine those together. So let's start with that. Combine the second and third equation together, and we see that the y's will cancel. 3z plus a negative z is 2z. 5 minus 1 is 4. Dividing both sides by 2, and z is equal to 2. Draw a column so we can keep everything situated. Now we could substitute 2 back into either one of the second or third equation to get y. When we substitute 2 in for z, we end up with y plus 6 is equal to 5. Subtracting 6 from both sides, y is equal to negative 1. So I already have two of my variables. Z is 2 and y is negative 1. I still need to find x. Now that I know z and y, I can substitute these two variables into the top equation. Simplify. X, negative 2 times negative 1 is plus 2. Plus 3 times 2 is 6 is equal to 9. Combine like terms. X plus 8 is equal to 9. Subtract 8 from both sides, and x is equal to 1. We could check our answers to make sure this is correct. We know that 1, negative 1, and 2 is our solution, and we write that as an ordered triple. So, to recap, the first thing I did was look for something that could possibly easily eliminate. So in this problem, we look for something to eliminate. In this case, we could see that if I work with these two equations, we can eliminate the y's. Then we use substitution to solve for the variable. And then we use substitution again. Let's look at another example. This one looks a little bit more complicated, but again, we want to make sure that we look for something that we can eliminate. And if you look at equations 1 and equation 3, notice that the z's are opposite pairs, so we can eliminate z. So let's add these two equations together first. Combining these two equations gives us 3x plus 2y is equal to 4, because the z's will cancel. Let's see if we can find something else that we can work with. I need another equation that would be x plus y so that I can combine and simplify. I do not have that. So if I add equation 2 and equation 3 together, 2 times equation 3, then I can make this work. Now I can't quite combine these two together yet. I need to do something with equation 3. Again, I want the z's to cancel so that I have x plus y. So if I multiply equation 3 by negative 2, that will work. So now when we draw our line and we combine, the z's will cancel. And I get negative x plus y is equal to negative 3. Now I have two equations that are just x and y So I'm looking at this equation and this equation. Let's write these equations up on top. In the next column, 3x plus 2y equals 4. Negative x plus y equals negative 3. I notice that I can eliminate the 3's if I multiply by 3, or I can eliminate the y's if I multiply by a negative 2. I will go ahead and use 3 here because it's nice. At this point, it's just like the previous lesson. So rewrite the first equation, rewrite the new equation, draw our line, and combine these two equations together. 5y is equal to negative 5, and dividing by 5, y is equal to negative 1. Now I know one of the variables. I need to find the other two. Since we already found negative x plus y equals to negative 3, if I substitute negative 1 in for y, I will find x. So substituting negative 1 in for y, I get negative x minus 1 equals negative 3. Add 1 to both sides, and negative x is equal to negative 2. Dividing by negative 1, x is equal to 2. So now I have two variables. I still need to find the third variable. Now use any one of these three equations to substitute in the values, and the third equation is the easiest. Substituting our values, x is 2, y is minus 1, plus z is equal to 2. So combining like terms, we get 1 plus z equals 2. Subtracting 1 from both sides. And z is equal to 1. So the ordered triple is 2, negative 1, comma 1. So let's really go back over this one. The first thing I noticed is this is not an easy equation to deal with. So I need to eliminate some letter first. And I chose to eliminate z because we noticed in equations 1 and 3 that the z's would go away if I combine those. But that leaves me with 3x plus 2y equals 4. So I take the combination of the middle equation this time with the last equation, and if I multiply the last equation by negative 2, the z's go away again. And that leaves negative x plus y equals negative 3. And that's good. That's what I want. So I have 3x plus 2y equals 4, and negative x plus y equals negative 3. I'm going to use both these equations right here and try to eliminate for another variable. And I notice I can eliminate the x's if I multiply by 3 all the way through the second equation. The 3's cancel, and this gives me y equals negative 1. So now I have one variable solved for. Plug this variable into either one of these equations. Does not matter which one, but negative x plus y equals negative 3 is simpler, so I choose that one. And we get x is equal to 2. Since I have two variables, I could substitute those two variables in any one of the three equations again, and I get my third variable.